Greetings. Welcome to Lecture 7, Part 2 for Life in the Universe. Still on my porch. The previous video, the sound seemed to come out okay, even though I can hear some machinery and traffic noise a couple blocks away. Seems to be good enough with my microphone. So stay out here in the nice weather while we've got it. So here we are going to finally finish this long unit of Unit B. This would have taken 4 full classes if we were meeting in person. And since, so 4 lectures, so more videos because there's more than 1 video per lecture. So what I want to do to conclude this astronomically historical part of things is basically go from the time of Newton up to about 1900 and just kind of take a look at some of the thinking about extraterrestrial life during that period of roughly a couple hundred years. Now, by Newton's time, basically everybody had accepted, just not quite, but just about everybody accepted that basically the Copernican idea that the Earth was a planet orbiting the sun was correct. And once that idea was widely accepted, then the idea of extraterrestrial life became quite common. And the thing is, though, that the reasons why most people, at least many scientists and non-scientists, tended to think that there would be extraterrestrial life, indeed intelligent extraterrestrial life, really based more on religious and philosophical reasons than for scientific reasons. Like I said, I think Galileo and Newton both did the most intelligent thing you could do on this, the most reasonable thing, and said that basically we don't have enough information to know. But I guess in the late 1600s into the 1700s, the kind of religio-philosophical point of view was that it would be a great waste of space if life indeed was not common, and that was one of the main motivations for it. So this is an illustration from a French book published in 1686, so roughly the same time as Newton's Principia. And in the center here, we have a representation of the solar system with the sun at the center and planets going around it, and then a depiction of other stars with their own planets, and the thought being that many, if not all of these planets, not just through other planets in the solar system, but these planets orbiting other stars would be inhabited and by intelligent beings. Now, the thing is that people thinking about it this way basically got to the point where they thought that basically everything was inhabited. So you see up at the top, there's something from an English brochure from the 1600s where the author claims he's actually discovered life on the moon. Remember, we started this unit with thinking about what the word world might mean in various contexts. If he thought he had demonstrated that, he was incorrect. But even things like comets were thought to be inhabited. A picture of Halley's comet down below. What we know about comets now would be extremely unlikely, at least if they had, certainly for them to have intelligent life. Maybe a few of them, maybe a few microbes, but we'll see about that later. And this might even seem odd to us today, but even the notion that the sun was inhabited was suggested. Now, obviously, even then, they had an idea that the surface of the sun had to be hot. Because if I just lean to where my face is in the sun, my face already feels warmer from it. And by the way, I did not plan on doing that from being outside today. That was good timing. Take advantage of opportunities when they arise. So, say in the 1700s, they would have known, okay, the surface of the sun's probably too hot. But they understood thermodynamics very poorly then. So they imagined that, yeah, maybe the outer layer of the sun is really hot and uninhabitable, but maybe there's this layer of insulating material, and maybe there's Earth-like conditions on the interior. No way that could work, as we now understand. But given what was known in 1750, 1800, 1700, yeah, maybe it would be plausible. However, once we got into the mid 1800s, though, uh, ideas about life elsewhere in the solar system became much less common. And there are a number of things happening. One was we were starting to understand physics better, had a better idea of figuring out what the physical nature of the planets would be, what the conditions would be like on other planets. And that led to a lot of this decline in belief in solar system life. And these two guys were responsible for a good bit of it. William Whewell was a British philosopher, scientist, clergyman. He was an Anglican priest. Actually, some people consider him to be the last true Renaissance man because his expertise spread over so many different disciplines, and somebody I need to learn more about than I know. And anyway, so in his astronomical writings, he was pointing out that from what we were learning about the physical nature of the other planets, at least within the solar system, not looking so good for life. Richard Proctor, who was an American who was a big popularizer of science and astronomy, kind of like Neil deGrasse Tyson is now, or Carl Sagan was a generation ago. And anyway, he too was more skeptical of the idea that other planets in the solar system would likely be inhabited. And what was being learned in this time that was contributing to this decline of belief, among these things. During the 1800s, we were really starting to figure out that the Earth was really old. More than a few thousand years old, but hundreds of millions of years old, if not a few billion. And the thing is, if the Earth was only a few thousand years old, and well, there's been human civilization for a few thousand years, and so that might lead you to believe that, well, any planet could have life is going to have advanced intelligent life. But when you realize that we've had intelligent life on Earth for a few thousand years, and the Earth is at least a few 100 million years old, that gets to be um, make it much less likely, that you'd think there's got to be intelligent life. It may seem obvious that to us, that a planet close to the sun is going to be hotter than a planet further from the sun, but you need to have some reasonable understanding of thermodynamics, which was really a branch of physics that was developed in the 19th century to get that. And so they're starting to realize that Venus and Mercury might be too hot, Mars and further out might be too cold. Spectroscopy is a method by which you can figure out what something is made of by analyzing the light you get from it. We're going to learn about that in our unit that includes light. So this is when that started to gain applied to astronomy, and realizing that atmospheres of other planets probably weren't quite like ours. And then this last part, the kinetic theory of gases, that refers to the understanding that gases are made of molecules. And by statistically analyzing the motion of those molecules, you can derive a lot of the properties of a gas. And realizing then, combining that with the idea of escape velocity, that something that is going fast enough will escape from the gravity of a planet, and realizing that some astronomical objects, like the moon and Mercury in particular, that their escape velocity is going to be so low, they're not going to hold on to any significant atmosphere, makes it extremely unlikely of having life on those surfaces. However, there was also a development in the late 1800s that led to at least for Mars, an increase in the thinking about life and even intelligent life on Mars. And that involves this discovery or at least a report by this Italian astronomer named Giovanni Schiaparelli of features on Mars that he called canali, indicated by these little wavy features that you see here in this map he drew based on his by eye observation of Mars. Canali in Italian means channels. Does not imply an artificial origin. However, the term was mistranslated into English as canals. And canals do imply, is a word that implies an artificial origin. And the really big cheerleader up into the early 1900s for this was an astronomer named Percival Lowell, who was from the Massachusetts Lowell family, a prominent and wealthy Massachusetts family. And he used his fortune to build his own observatory out in Arizona, largely inspired for the discovery of Mars, or for the observation of Mars. It's one of the most significant private, that is non-government operated observatories that is not associated with a university. And he was a big cheerleader for this idea. And here's his map of Mars drawn uh, again from his just looking through the telescope by eye. And you see all these kind of straight features here. And what he imagined that these were is he imagined there was actually a dying civilization on Mars. Mars, according to him, was getting colder and drier. And so the canals represented the efforts of that civilization to try and, by getting water from Mars's ice caps at the poles, to try and irrigate their crops to the extent they could. Some astronomers saw them, others didn't. And so here's the thing. They were only visible for the people who claimed to see them for moments when the atmosphere was particularly sharp. Trying to photograph Mars, they wouldn't show up, and the canal proponent said, well, that's because with that long exposure for a photograph, the atmosphere gets to be too blurry and you can't do them. You can only those moments of sharpness where you can see them. But you should always be very cautious of something that you're only detecting at the limits of whatever your detection method is, in this case, human vision. And the fact that not everybody could see them should have been maybe a bigger warning. And as it turns out, they're not real. So right here is a comparison of, again, some other maps. This by the third astronomer who claimed to see the canals, and what his drawings of Mars projected onto a globe on the right. And then on the left, we have photographs of Mars from the Hubble Space Telescope um, on the left. And you can see from the photograph here, the larger features, like for example, this darker feature, a little bit lighter through here, that's something that's real. This feature here, you see that's real here. But the finer details here, where the canals are, they just aren't there. And the thing is, the human brain is very good at finding patterns, even when those patterns aren't really there. So looking at, well, I know if I look at the stucco pattern here, I'll very quickly find something that my brain will want to interpret a face. There's one with the eyes, nose, and the mouth, even though it's just a random pattern there. At the limit of vision, this is very similar to a phenomenon I know I've encountered many times while driving along on the interstate. Looking ahead, I suddenly see something and say, oh, wait, is that a state trooper? Better slow down. But no, as I get closer, it's just the guardrail that my brain interpreted a different way when it was at the limits of what I could see. Of course, now it would have been a lot better if Mars had cannoli instead of canali, and then would all be rushing there. No canals, definitely. Cannoli, maybe still an open question. Now, with this controversy, this had a lot to do with how the possibility of a civilization on Mars had a lot to do with how Mars was depicted in popular culture, the late 1800s, early 1900s, including the way it was depicted in science fiction. So on the left, we have The War of the Worlds by H.G. Wells, which has been adapted many times. Incidentally, the original novel was inspired by the genocide the British were doing at the time against the natives of Tasmania. And Wells and his brother were talking about it, and they disapproved of it. And Wells's brother said, well, how would the English feel if Martians landed in London, started doing this to us? And that was the inspiration of the book. And the behavior of the Martians and wiping us out in the book is, direct parallels are drawn with how with human behavior in that. Something I have not seen in any of the cinematic depictions of the movie I've seen, although I haven't, of any of the book I've seen, although I haven't seen all of the cinematic depictions of it. On the right, Edgar Rice Burroughs wrote a series of books um, about a guy named John Carter who was transported to Mars and his adventures there. And some Martians were basically human, others were tall green guys with 4 arms. Um, anyway, he wrote a number of books in it along this line. There's one of them. Burroughs, incidentally, is also famous as the creator of Tarzan of the Apes. Anyway, there was a movie from roughly a decade ago called John Carter that was based on that. I guess we're hoping was going to jumpstart a franchise, and it didn't. Anyway, I've never read any of Burroughs's Mars books. The little bits of Burroughs I've read, he wasn't a great writer, but I guess I probably should read at least a couple of them just to just for my own knowledge. And I got a little bit more, but here's your secret code: Mars Attacks. Great movie from about 20 years ago. Very funny movie about the Martian invasion of Earth, which I highly recommend. Mars Attacks. All right, now another thing that led to decline in belief during this historical time and maybe an extraterrestrial life more related to outside the solar system. We'll talk about formation of stars and planets later in the course. But basically from the 18th century until around the beginning of the 20th, around 1900 or so, the way that astronomers thought that stars would probably form were that we'd expect planets to form along with them. But then first half roughly of the 20th century up to about 1950 or thereabouts, a different model for how we thought planets formed was most popular. And this particular model, if it was correct, would mean that planets would be very rare. Very few stars would have them. And if very few stars had planets, then we would expect extraterrestrial life to be very rare. Since about 1950 then, our understanding of how we think planets form has changed again. And our current understanding is that we would expect planets to be a very common byproduct of star formation. But of course, our theoretical ideas aren't what's really important here. What do observations show? And we do have observations now that make it very clear that planets are indeed very common. So if you like the idea of life being common in the universe, at least there do seem to be a lot of planets, which means that we've got a reasonably good chance of at least having the right kind of real estate for life. Whether or not the life is there or not is a separate question. Definitely life on the porch behind me, as you can see some of my wife's plants, where what I try and do with them if she goes out of town is I basically try and keep them alive. She takes care of them. Anyway, that finally concludes Unit B, along with Lecture 7. I'll let you know when the Lecture 8 videos are up on YouTube. With Lecture 8, we will be moving on into Unit C, which will go back to biology for a few lectures. So we'll meet again in Lecture 8. We'll start Unit C.